Hey everyone, in this video we'll learn all about even and odd functions. So as you can see right here, we have the function f of x equals x squared graphed. Right over here in blue, we have this parabola graphed. And we are going to talk about the difference between even and odd functions. So this function that we have here, f of x equals x squared, this is actually an even function. And what makes this an even function is that it is symmetric about the y-axis. So if we take a look at the y-axis, this entire line right here, the y-axis, then our parabola f of x equals x squared is symmetric to relative to the y-axis. This side is symmetric to this side, as you can see. Let's undo that. So that's what makes this an even function. It is symmetric about the y-axis. And one more thing that makes a function even is for every even function, for every x value, for every x value, f of x equals f of negative x. So this is almost the definition of an even function. For every single x value, f of x equals f of negative x. So what does that mean? Well, let's throw in a few examples. Let's test some x values. Let's try f of 1. So f of 1 equals f of negative 1. Is this true? Does f of 1 equal f of negative 1? Well, it is true, because what is f of 1 right here? What is f of 1 looking at this parabola? So f of 1 right here is 1. So f of 1 is 1. And then what's f of negative 1? So f of negative 1 right here is 1. So 1 equals 1. So f of negative 1 is 1 and f of 1 is 1. That is true. Let's test a couple more values. Let's try f of negative, so f of 2 and f of negative 2. Let's evaluate this first. What's f of 2? F of 2 up here is 4. So f of 2 is 4. So that is 4 equals, and what's f of negative 2? So f of negative 2 is also 4, right here. So f of negative 2 is 4. So f of 2 equals f of negative 2. 4 equals 4. So that's true as well. And the same thing works with 3. If we go ahead and try 3 real quick. So f of 3 is the same thing as f of negative 3. Why? Because f of 3, again looking at the graph, f of 3 is 9. And then f of negative 3 is also 9. So both equal 9, so 9 equals 9. And there we go, that works as well. So for all the x values, we've just shown that f of x equals f of negative x. So that's what makes f of x equals x squared an even function. And that's really what an even function is. For every x value, f of x equals f of negative x. And also, it is symmetric on a graph about the y-axis right here. It is symmetric as well. And one more thing too about even functions. So let's go ahead and just erase this. Let's just get rid of that. So even functions. So this is one example of an even function, f of x equals x squared. Another example is f of x equals x to the 4th. F of x equals x to the 6th. Also x to the 8th, x to the 10th. So x to the any even power number, if you have a function in this form, x to the any even powered number, so if the power of x is even, it's an even number, then it will always be an even function. So x to the 4th is an even function, x to the 6th is an even function, x to the 8th is an even function, even x to the 1000th power. 1000th is an even number, so x to the 1000 would also be an even function. It would be very difficult to graph. You'd need a lot of graphing paper, but that would be an even function as well. Great, so that's those are even functions, and now let's talk about odd functions. So let's erase all this. Let's erase this parabola right here. Okay, so odd functions. So odd functions. And we are going to graph the odd function in orange. F of x equals x cubed, or x to the 3rd. So x to the 3rd, and it is graphed like this. So 1, 1, 2, 8, 0, 0, negative 1, negative 1, negative 2, negative 8. Let me actually extend the graph just a little bit so that it goes to negative 8. So negative 7 and negative 8. Negative 2, negative 8. Okay. So let's go ahead and just connect this. And then we will connect this as well. Let's try that again. We'll connect this spot as well. And there we go. We've graphed f of x equals x cubed in orange. So f of x equals x cubed, we've graphed it. And this is an odd function. And what makes this an odd function by looking at the graph is that this is symmetric about the origin. So if you take a look at the origin, it's symmetric about the origin, because if you just take a look at the origin, 0, 0, you have this piece right here. And then on the other side, you have this piece going in the opposite direction. And if you rotate it, so this is in the first quadrant, and if you rotate it all the way to the third quadrant, then if you rotate this piece over here into the third quadrant over here, then you will come up with this piece. So that's what makes this an odd function by looking at the graph. Again, it is symmetric about the origin. And now also just taking a look at f of x equals x cubed, the power is 3, x to the 3rd power. And 3 is an odd number. So you can also guess if we were able to graph f of x equals x to the 5th, x to the 7th, x to the 9th, and every odd number, then these would all be odd functions. X to the 5th would be odd, x to the 7th would be odd, x to the 9th would be odd, and x to the 1001, because 1001 is an odd number, x to the 1001 power would also be an odd function. And now let's talk about the definition of an odd function, just in terms of its formula. So a function is odd if for every x value, so if for all x, f of x equals, let me write this in red, negative f of negative x. So for every x value, f of x is negative f of negative x. Let's go through an example so this makes sense. Let's say we had f of 1. So if this was an odd function, then f of 1 should be the same as negative f of negative 1. So let's evaluate this. What's f of 1? Well, f of 1, just by looking at this graph, is 1. So f of 1 is 1. And what's f of negative 1? So f of negative 1, looking at this graph, is negative 1. So we have negative and then negative 1. But what's a negative negative? That's a positive. So 1 equals positive 1, which is true. 1 equals 1. So far it's true for the input 1. And we'll try one more input just to show our point. Let's go ahead and just try 3. So f of 3, does that equal negative f of negative 3? So what's f of 3? F of 3, if we can just go ahead and evaluate it algebraically. F of 3 is 3 cubed. So f of 3 is 3 cubed. 3 cubed is 27. So 27 equals, and we have negative, what's f of negative 3? So let's evaluate that algebraically as well. So f of negative 3 equals negative 3 cubed. So negative 3 cubed is negative 27. So negative 27. And again, the negative and the negative become a positive. So this just comes out to 27 equals positive 27, which checks out. So that satisfies that rule as well. So there we go. For every x value, f of x will be equal to negative f of negative x. And that's what makes a function an odd function. So those are the differences between even and odd functions. I hope this video helps to understand that, and if you have any questions at all, please leave them down in the comments below, and thank you for watching.